guess we're starting this thing. I'm super nervous, extremely. Like that guy said in the beginning, like I'm also an introvert, this kind of thing. So whatever. Today we're talking about API documentation, in particular with RAML, stuff like that. It's written here in small letters that it's going to be an API modeling rant. Hopefully it's not going to be like this. We're just going to cover some basics, stuff like that. So first of all, no bullshit, no stuff about who we are and stuff like that. We just decided to present together because we worked on a huge project with a lot of sets of APIs, stuff like that. We used RAML for documentation. We had some kind of different perspectives on how the perfect documentation should be, how should it like, should it be like, look like, I was trying to say. And yeah, and we thought it's going to be fun to put all this experience in one talk. That's what we try to do. So, Mitya, yes, that's him. Me, Vladimir. Hello.
Hello.
Hello. Ciao. Ciao. Ci sono molti italiani oggi. Okay, so there are two parts, obviously. So the first part is mine. I'm gonna just cover some basics, do some basic comparisons, why it's useful and why it's not useful. And then the next part, Mitya will follow with some more like deep stuff. He'll give you some checklists, what you should do, and give you some takeaways. So that's how it's structured. So you know you're prepared. So wait for his part. It's gonna be exciting, I hope. I'm not sure. Okay, so we do have some assumptions about you guys, about the audience here. So either, the first category of people, either you haven't heard of API description languages at all, or you're not convinced it's useful, it sucks, stuff like that. The second category of people, second bucket, you kind of want to use it, but you have some trouble choosing which one to use. Should you really try that? You're kind of not really convinced yet, but you tried something, you made the first step. And the third category of people who actually done a lot of stuff in this field, use some languages, they are proficient. So we're kind of trying to cover basics here. But anyway, I think it would be nice to talk to people who are, really got a lot of experience in, in API description languages as well. So we try to cover all the basics. So enough with meta stuff. Now let's get started. So let's first just small definition here. What's API description language is? Well, it's a structured document either in XML, JSON, Markdown, whatever actually, any document which is machine readable. And the way you create it is written here. So either you use top-down approach, which means you first create a definition, and then only you create an API to match it. The second approach is bottom-up, which means you first create the API, the actual backend, and then you create documentation based on that. So there are two approaches. We're gonna kind of try to stick to the first one, top-down approach. Why? Because it's very useful. For example, you could do mocking based on that, so you can create a huge set of those endpoints, and mock it, feed to some special kind of software, just put it on your server, and it's gonna serve you like a real server, but it's gonna be mocks. So it's quite useful. And you can achieve that using top-down approach. So why do we care? Why do we care? Why would you care? First, let's take a look at this problem from business point of view. So first thing is that probably in your teams, with your teammates, you had this problem with expectation gaps. So for example, Alice wanted Bob to code some API to deliver some particular set of endpoints. She expected this kind of response body types, something like that, some parameters and stuff like that. And in reality, a couple of days passed. Bob tried to deliver that, and Alice is not happy. Some things are not the way she expected them to be. So she has also to redo some stuff she was trying to code in the meantime. API modeling languages surely can solve this problem because they can create this model, collaborate on that a little bit, then they will have no expectation gaps. Another thing why it's useful is that if you have this model already defined, and you have a team not of two people, consisting not of two people, but many people, some contractors, some remote offices, stuff like that, it's very nice for those people to know how your API is going to look like. For example, we had the same situation, like we had mobile developers somewhere in there, and we just provided them the documentation. It was not yet implemented in the backend. They saw it, they understood how to structure their Android application, they did that. And in the meantime, we were coding the backend. So it was very nice, not time consuming. Like, of course, you would have some problems, some small issues, but it's not that bad. And API modeling helps your team to load distribution. It's also here in business because, for example, in our company we have not only one project going, but a couple of projects. Probably it's a common situation for you as well. So when you want to start a new project, you kind of need to allocate people for that. And to do that, well, it's quite hard to do that if you just put all the people to stop at some particular deadline and then start a project at that time. So what you could do, you could just get one front-end guy, for example, and make him write this documentation, collaborate with CTO, I don't know, team lead, whatever, maybe some backend people. They create this documentation first. They already, when they created that, have some understanding of the system. They broke it down. And they could actually already start coding. They code using those mocks. They started already some, they have some design probably. They started already to put some front-end logic or whatever. Maybe you have backend, a lot of backends, so like you have microservices, fancy microservices that were mentioned earlier. So that's the situation we were also in, and it helped us pretty much a lot. Yeah, so now let's take a look at this problem from developer point of view. Maybe it's more close to you, I'm not sure. So you probably know that software engineering is all about interfaces. It's all about having constraints and stuff like that. For example, TDD approaches, they make you write contracts first, tests first. Think about it in your head, like break it down in small pieces before. It also helps you with estimation, for example, if you need to do that. And the same thing applies to API description languages. If you have your API broken down in pieces, discussed, and stuff like that, it's more predictable. For you, it leads to better quality of your code. And the second point here is also, you can probably see that while you do that, while you discover those problems with your API, your future API, you see the issues, what could be done, what could be like avoided, what should you put really there, is it according to the specification and stuff like that. So it's very useful to think about it in advance. And also the common situation that some projects lack documentation. And here you could create this document. For example, my case, I would make you an example, make a good example here. I coded some APIs, I needed to then adjust them after 2 months of work, and I couldn't understand like who actually did that. I saw Git blame, it was me, so probably I should know that, but I couldn't remember. And I looked at just documentation, how it should look like, the responses, requests, and stuff like that. We had some notes there, and it's a nice place to put all your documentation actually. So it helped us also a lot. It's based on our experience. So I hope it helped you to kind of prove that it's useful. And now we would like you to go back in time and see what was happening before. So in those times, in ancient times. So people used VSDL, VADL, XSD schemas to validate the responses in all those XML times, 2000 something. Probably some of you had some experience with that. Nothing wrong with that. Everybody likes XML, probably. Everybody. I liked it. I liked Java. You put Java, Spring, all the stuff. It all works. A lot of XML. Really fun thing. And it looked like this. That's example with WADL. You don't need really to pay attention to what's in there. Just request, response, obvious stuff. But it was all in XML, so you just should be scared of that, and that's it. But then the miracle happened. And AS kind of years came. So after Swagger, I would call it. So Swagger appeared in 2011. It was a nice breakthrough. And through all this time, you could see till nowadays, there were a lot of technologies appearing, like RAML, API Blueprint, many of them, actually more, a lot more. And they made quite a huge improvement in the way they work. So that was great. We are here right now in this hype curve. We actually passed the peak. So the peak was probably at about 2013, when all the languages got really mature. They had all the features in there. So now we have all these languages, Swagger, RAML, their features are converged. They converged into something similar. You would get probably the same kind of experience with any description language, which is good. So we passed this hype. Probably the plateau of adoption is going to come later. So nothing really exciting is happening in these days, I think. So it's nice to start finally using those description languages. What we wanted to do is to compare a little bit Swagger and RAML, just because we have to. Because RAML we use, and Swagger is, well, you cannot get away without mentioning it. It's like everywhere, so you have to mention it. Let's quickly recap on that, because some of you have probably attended the talk about that earlier. Just some recap. So it was started for a service called Warnik. That's basically a set of APIs. So they had first APIs, they wanted to document it, which means it's a bottom-up approach. So that's how it was created, the version 1.0. Then version 2.0 came. It was a major improvement as well. They enabled YAML support, and they made a top-down approach possible and easy to use. So you could first design your API, collaborate on that, and only then code it. That's a nice thing. And reusing capabilities in Swagger are okay. They're usable, everything is okay, but not perfect, I would say. So they're kind of superficial. That's kind of emo, so let's not rant about it. We're gonna cover this in later in the part later, so don't blame me for putting this here. And the thing you should put all your attention to is that Swagger 2.0 became Open API initiative that was mentioned before. Basically, it's an initiative backed by Google, IBM into it, Microsoft. So all the companies try to put a lot of kind of attention to this Swagger by converting it to Open API and making it kind of standard, which, well, you should know about this when you use it. Basically, that's how it looks. Very simplified example. Paths, you have one endpoint here with just search capabilities and a path definition, which looks like JSON schema on the right-hand side. That's pretty much basic, but at least you get a sense how it looks in YAML. Community and tooling of Swagger are the community is highly active. It's very vibrant. So they created a lot of tools. There are a lot of support, including the tool from Nicola, I think. I couldn't, stop. Sure. So like a lot of traction there and a lot of tooling. Swagger is used by many companies, Hootsuite, Zalando, others, possibly you, because many people use DRF, which is Django REST framework, and Swagger was baked in early in the days of DRF. So probably you've used it. And the tooling, like Swagger UI editor, it enable you to create your API definition in a cloud-based editor, like with nicely generated HTML output. That's very nice feature. Things you could use that for sure. But let's take a look at RAML. RAML was developed by a company called MuleSoft. For those who don't know the company, the company's business is about APIs, making API secure, kind of making some proxies for that. But you should know that RAML has a work group, so it's independent from MuleSoft. But MuleSoft tries to sponsor it, tries to promote it, things like that. RAML is YAML based. It's the only language supported is YAML, and it supports top-down approach, which means again that you first create a document, a model, and then you code your API to match it. The reason RAML was created, version 0.8, is because they wanted to put a lot of reusability there, reuse capabilities. So they have resource types and traits to extract common patterns, to make it all work nicely, like the way you do, like very clear and dry. That's why it was actually created. Swagger caught up after that. But anyway, in our opinion, RAML kind of wins the battle here in extracting common data, common entities from your specification. Like you might argue with us later if you want. Here is a quick definition. Same thing as in the previous presentation if you attended. They look exactly the same, almost exactly the same, just some keywords are different. On the left-hand side, you see one endpoint for pets, and on the right-hand side, you see just a pet definition. Also looks like a JSON schema, a little bit adapted. So tooling is great, but notice the community is not as active as for Swagger. But anyway, the tool is liked, I would say, by many companies. Spotify, VMware, many kind of enterprise companies. They like the solid features of RAML, of reuse. So early in its development stages, a lot of attention was given by kind of enterprise companies to RAML. Tools will be covered by Mitya later on. So I'm not mentioning them here, but they exist. They are nice. We use them. Sometimes you have to patch something, like open a pull request, but that's what we like to do, actually, right? So you got your chance. You got your minute of fame to do a pull request and patch something. Which one should you use, actually? Well, I don't know. I know. Swagger is great, but, well, we liked RAML. We used it in many projects. We had some nice experience. We had some nice tools. We know the patterns. And a lot of things we can reuse. I told you about. That's probably the kill feature, reuse capabilities. Anyway, the thought I wanted to put in your head now is that you should use at least any description language you use would be a good solution. Like, there's no need to start a rant about that. Just use any. If you really like want to choose, well, we advise to use RAML, but any description language is better than no description language. That's the idea, the whole point. And now, are you ready for that? Now we have, like, I'm passing my word to Mitya, who's gonna talk about some cool things, some tools and stuff like that. So please welcome.
Thank you. Would you please pass me the clicker?
No.
No? Okay, thank you. Well, I personally think, well, hello. My name is Mitya. And I personally think that was an awesome overview of how things are. And now we're getting into more of a practical part of our speech. And let's recall the Joel test. Most of you probably heard of. And it's a classic list of simple questions. And you're answering them, and you're getting the clear overview of how your situation is with terms of software development. But we have an idea of making something similar just for API documentation. So let's move to it. We name it the bodies test, because why not? And point one is, do you use a Hypermedia type to define responses? Quick overview of what do I mean. There are data definition languages, the special formats which used for data modeling and data validation. And among them, there are Hypermedia types, which are the special formats to define requests and responses, and they provide a way to link your API elements, endpoints, your documentation, your linked resources, and potential actions all together. And so let's take a look. There are plenty of them that are comparable with RAML, and they are all JSON-based. Let's take a look at JSON schema. Probably, again, most of you already know that, but still, JSON schema based on the concept from previously historical XML schemas, and but it's JSON-based. It's human readable, self-describing, and the same idea as in the XML schemas part is that you could use the same serialization and deserialization tools, both for the schema and for the data. And it looks like this, very simple. You see there are additional dictionaries among the data, dictionaries with describing types of fields, and you could also describe what fields are required to be present in that JSON. and a few other things. Then there are JSON API, which is also very highly popular and trendy, and it's basically a specification for building API in JSON. You see there are plenty of API in the world, and each one is different, and there are infinite number of ways basically to implement any feature. So people need to talk between each other and find the way to achieve shared expectations and to establish some sort of contract how to make APIs. And in our opinion, JSON API is some sort of better from many of its contestants because it's free from some limitations, like a limitation of hell, which is also some sort of popular. And it looks like this, basically. You see there are also additional dictionaries again with links to related resources. So you could just navigate through these links and see the structure automatically. So the point one is basically that you could first step for creating neat API documentation system is to choose Hypermedia type and start defining your request and responses in it. Point two is about API design tools, and by API design tools I mean first of there are handy IDEs like your JetBrains IDE, beloved ones, and they are really powerful. They provide highlighting, the ways to test, validate, do everything at once, and they're real nice. You should try it out, but if you want, it's okay, because you could just use sort of plugin for any plugin for YAML, for example, since RAML is just superset of YAML. And there are also tools for editing JSON schemas, and there are generators, so you could just pass your JSON into such generator and get in return the JSON schema. Note that no generator can absolutely 100% predict all your format quirks. It's obvious. So you should still write the absent part by yourself, but still they're helping, they're saving your time, and you should take a look at them. Point three, do you organize your documentation properly? And for end user, it means that the structure of your documentation meets the structure of your API. And it's the first thing. And the second thing is that your documentation helps your user to start writing, to start making API calls, working with API quickly, which means it covers the very basic things like authentication or something like that. And the RAML itself is awesome to achieve both of that because it's by design to match the API structure, for example. As for developer, organization of your documentation means, most of all, it means to properly organize the storing and sharing your JSON schemas. In many cases, you want your schemas stored in a separate repository, so you could just, I don't know, remotely get it via HTTP or include them as Git submodule. Everywhere you need them in your backend repository, your front-end repository, your test repository, or others. And the great thing here is that JSON schemas are reusable. So say you are a team or a company, you have a few projects, and in the one project you defined previously a way to you established a contract on your API, and you have those JSON schemas. So later on you could just use the same schemas on the other project to make sure your previously established contract still on, which is nice, I guess. Point four: do you take advantage of reusable RAML constructions? As Vladimir previously said, RAML is awesome in terms of reusable features. As Pythonistas, you all probably want to keep all of things in your life dry. Don't repeat yourself. And RAML here comes in handy. It has includes, which mean you could just inline one file to another, JSON schema to RAML, RAML to RAML, you name it. And there are resource types, which means you could just take the whole structure of methods from some IP endpoint and just apply it to another IP endpoint to achieve the same behavior of your resource. And there are traits. Traits are basically reusable attributes like authentication, sortability, searchability, which means you define this feature once and then just plug it in, plug it out whenever you want. Point 5, is your documentation interactive for end user? Well, again, most of you probably heard of or familiar with Django REST framework. It's popular. And Django REST framework, as I don't know, Twitter, Facebook APIs has the way to make in-browser interactive testing for API calls. It's providing some workspace for it, which come in handy, and visualizing structure. Well, in your RAML ecosystem, you could very sort of easily achieve the same functionality. There are also a way to get versioned, forkable and shareable API calls, like project Jupyter, previously IPython notebook. So you could achieve the same the similar functionality here, which is very nice. And all of this not only good for end user, but it also speeds up their development. Point 6, does your whole team collaborate on API design? Well, this is probably the key point, one of the main points, and by this we mean there are in your team or between the teams even, you have usually some sort of flow of interaction between team members and between teams, and this flow of interaction has its usual issues like expectation gap, which was mentioned by Vladimir, and like I don't know, interaction gap or something like that. Many issues, and so such interactions between people needs to be done obviously async way. So no one could wait each other, but still they have some sort of contract they could rely on. And you should also ideally be able to walk any direction. Backend first, then move to front end, integrate it and deploy. Or front end first, or tests first, you name it. So that's the case. That's the problem where your API documentation system could come in handy, providing clear and persistent feedback loop. And by such loop, I mean, first of all, mocking. So the basic idea is simple. You mock the absent component of your system, of your feature, and you just integrate it, you use it as you want it, and then when the time comes, because you already established a persistent and clear and reliable contract within your project, within your team, you could easily replace this mock with real component, which is great, I think. And the mocking, I would say also the mocking in RAML ecosystem is really done easily. There are plenty of tools, generators, servers, so you just set up it once for a while and here you go. You're up, you're good to go. Point 7, do you automate test and validation of your requests and responses? And it's not enough to just have your documentation written and your schemas written, but you want to perform automatic validation for your requests and responses. And most of the times, a good idea is to perform such validation on your test runs. So basically, you have your API, you're making tests, they're making test calls. And while they do that, they also check if your requests and responses comply to your JSON schemas, which is done fully automatically. And here we go to the main thought here, main point here, which is schemas. Schemas are a linking element in such system. Schemas are providing a way to connect, to truly connect, establish a connect between your code and between your documentation. So when, say, you update your API structure, API call, and your, say, response got the changes, your tests will fall, and your tests would say you about that response doesn't comply to schema. So you go to the test, you repair your schemas, so your documentation doesn't get outdated. So when your documentation gets outdated, your test will be broken, or vice versa. So schemas here linking the code to documentation, it's really great, I think. And there are also sort of question which data to use on test calls and what data to use on examples in your documentation. And there are two main approaches. The first approach, which are highly popular, is to use fixtures and such of manually written data. And the second approach is to generate such data automatically. It means factories, probably. And we personally think that there is an issue with fixtures, and that issue is it's sort of hard to keep them up to date. Well, it's really annoying. You should every time that something changes, you should go to your response JSON if you remember to do that, because it's not linked to another to the whole system, and update that JSON, and you could just make a mistake while doing that, and this is not nice at all. And there are probably an issue with factories. Well, I've talked with some people I'm familiar with, and they just said me, well, what do you do? We don't like Java. We're Pythonistas, and can't blame them. But still, we Vladimir thinks there's nothing wrong with using factories. Python has great support for them, and Django and other frameworks too. So factories is our choice here. We're advised to using automatically generated data with RAML. Point 8 is, do you have your documentation up to date and easily accessible to the team? You see, doesn't matter much do you have private or public API. You probably wanted to build it into HTML, serve it via HTTP, and you want also the ability to build it on demand locally and automatically on your continuous integration. And RAML providing easy and extensive ways to do that. Again, you could just configure it once and then it just works. And also there are few handy tweaks. You should use them to get the full automation. There are auto-reload watchers for your source code. There are ways to auto-open your browser page with documentation. Many small and not that small things. So they are all handy. We advise you to take power of them. And the last but not least question is, does your API itself follows best practices? And it doesn't that good if since your API documentation is very clear, it's up to date, it's I don't know, very good. When if your API itself not stable, not properly versionated, not flexible, you know these rules better than me. So when you start working with your API documentation, you probably start notice any issues with your API itself, and this is great actually. So your documentation helps you to find and fix inconveniences or issues with your API, so you could get it to the better state also. Well, some takeaways here are, first of all, obviously lots of daily pain removed. It's our experience on our cases, and not only from the developer's point of view, but from business point of view, from manager point of view too, because there are no unexplained integration gaps which you could not explain to your manager, why you spend a lot of time to fixing the problems which are not supposed to be existing. Also, this is very good for new developers joining, because they can just dive in and start writing code, implementing features, instead of trying to establish understanding of how it all works in your team and your project. Well, we again advise you to generate more of JSON request responses, test data and examples instead of manually writing them, at least with RAML. And another point is that the whole system costs its price. The price, in our opinion, is reasonable, but you still have to pay it because documentation gets outdated. And the last point is that you should, at maximum, use the tools, as the tooling in RAML, as in Swagger, is very rich, extensive, and it covers all you need. You just have you just make a cure, and you should automate everything. Well, that's basically all, I guess. Thank you all for coming. Grazie mille. We just like to say, as a last thing probably, that this topic is sort of big, and we just wanted to share our experience, our thought on it, and we'd like to invite you to open the dialogue and ask your questions. We would glad to answer them.
You're right, but I'm gonna hide here from all of you.
Okay.
What was that? Oh, nobody hears me.
Yeah.
Oh, that's that.
Okay, questions?
Hello. We have one. Don't shame us, please.
3 at least.
We're good guys.
The first, thank you
many
very much for
Jesus
your
Christ. Either.
great speech. The first question is, what about
Hi.
using RAML for non-REST APIs? For example, I write a good REST API and I want to support MQP API, for example, as a subset of my APIs. And we have 2 points of truth in this situation. Like, I describe my RAML, good REST API RAML, and then I go to conference, for example, or RTD, and also write the same API for like the second time. Like, any options here?
I'm stuck. Well, come on. You're the man of today.
Would you please repeat the... No, not the whole question.
Shortly.
Repeat the example you provided for such API. You don't mean GraphQL APIs or...
No, for example, I have a REST API and based on HTTP and everything is okay. And also I need to support AMQP API, for example, for my servers, because it's like enterprise, something like this. I want to communicate not only HTTP, like also
HTTP is a nice tool. I like it also. Yeah.
Yeah, MQPy is also needed, for example, for some reason.
Yeah. Well, do you want to say something about that?
It's MQPy message. I
Yes,
just
yes, yes.
Or
That's the
three,
didn't
Well,
catch it.
whatever.
or
Let me
pronunciation.
try to
or
to
some
say
kind of RPC, for example, and not problem with
Yeah,
MQPy.
well,
not only HTTP.
Well, I guess not suitable.
Well,
Am I
like
right?
RAML is based obviously for like HTTP, but well, sure. Like I cannot say like with 100% certainty. I haven't investigated that, but I feel with something here in my body that probably it's not suitable. But it's a good idea. I mean, like there was a person like in that talk, like a couple of talks before, who was asking about protocol buffers, about Swift and stuff like that. Was it you? No. So like
Me.
really, oh, awesome. No, I think it's kind of overkill there. Like maybe you can somehow stick there some stuff because, for example, JSON schema. Probably you could put something instead of JSON schema there.
Yeah. You see, you could configure the RAML JSON schema, whatever you want, to suit your needs here. But it's like using not the right tool for the situation, because this set of tools was designed for REST.
Yeah,
most of the
more or
times.
less.
So
But you could
I
you
would-
could
I
hack
would-
it
wouldn't
probably. You
probably-
could hack it.
you could with hacking, but I shouldn't. I wouldn't do that.
But I'm gonna research
reason.
actually. Just after this talk, I'm gonna research. I'm very curious about that. Thank you for asking. I'm super curious. Next API I'm gonna do it will be in protocol buffers. Awesome.
Wait. You wanted to
No, I don't-
your next
whatever.
API being GraphQL.
No, GraphQL sucks. I hate it. Whatever.
say that.
Okay, so you had another question. I'm sorry. Like
Okay.
this is the type of question when we say like we don't know the answer. Sorry, let's talk later.
Okay, thank you. Yet another one simple question.
For him.
What
Good
about
idea.
some extra formatting in RAML? For example, recently I have a problem. Just add a warning about this API is not implemented yet, something like this, and no possible. Like, I haven't found any possibilities. It's my fault, or it's really
Possibilities for to mark some API is not implemented, kind of.
to add more formatting, like warnings, infos, messages. Example, I don't know, code examples, something
Well,
like
for
this.
example, in RAML there are traits, so you could mark your APIs as some special kind of I don't know, not implemented. And well, what we did there, like I was just in plain text and description writing like in bold case, like, hey guys, don't use it yet, don't even try.
No
That's what
problem.
I did. But probably you could be a smart guy and use traits.
Well,
I'm not that smart as you and Mitya also. So I was just like putting some markdown there, like, hey, don't use that, please. Wait a little bit. Tomorrow probably I'm gonna do that. So that was my solution, but probably there are smart solutions.
Well, you see, okay, Vladimir probably is right. So there are.
I'm right about what?
I sum
don't know.
up. There are two solutions in here. The simple one is you just write simple small markdown with text of your error, and then you just simply include that markdown in your documentation as an answer for every IP in the method which is not implemented yet. But it's a dumb way to
That's exactly what we
achieve
need.
that.
Dumb ways work usually.
Okay,
They never fail. So
and the smart way is, I guess, it's trait. So you define a trait, say not implemented trait, and then you just plug, and then you just навешивать как будет.
как это будет навешивать? Подскажите.
You just plug in that trait into
Okay.
IP endpoints where you need it.
I see. Thank you.
I guess that's it.
Oh, there's the question. Okay.
I have yet another question.
Oh, okay.
Could you? Is it possible to auto-validate somehow this API, like spec and with code, or just you need to code all these tests manually, like?
Well, it's machine readable. It's YAML, so you could do that.
But
That's possible. We didn't do that in our
No
project.
existing tools.
Probably. Well, I cannot say with 100% like certainty again, but we didn't use that. We had tests which tested some. Well, I have to complain. Don't kill me here. We had some integration tests which were slow.
not?
I'm sorry. I'm very sorry. I'm not gonna do that again in my life. But we had some integration tests which were slow and like, all this stuff. And they actually tested that, and we had some more logic there going, not only JSON like responses and stuff like that, but also, I don't know, some basic things like if that was created or something. That was duplicate logic, but yeah, that's the moment when I say I feel badly about that.
Okay, thank you.
Sure, you're welcome. Moment of shame.
Yeah, thanks guys. Any question more? No, okay, everybody start.